Greetings and welcome, friends. Today we're starting a brand new chapter. We're talking about statistics and data analysis. Whew, man, good stuff. And we just finished our content on probability, and statistics kind of can go pretty well hand in hand with that, which is really nice because we've had, we understood the concept of kind of like experimental probability, where if like I flip a coin 1,000 times, I could see how many outcomes I got. And the theoretical probability of I was able to actually say like, well, 1/2 to the 1,000th power would be the exact, probability of say getting tails 1,000 times in a row. And with the experimental side of probability, you end up getting a lot of data and statistics, and you're able to do some stuff with that data. Today we're specifically talking about the frequency distribution. So frequency, think about how frequently something occurs, and a distribution is kind of arranging, distributing data in different arrangements. But today we're specifically talking about that, but more broadly I want to talk about a couple different ways of visually representing data. So a moment ago we had just gathered data about fruit that Math 4 people like, and there's only 5 of us in the room, including the teacher, so represent. I suppose I should have maybe sent out some sort of Google form internet survey for all of our viewers online. The ones of you. I can't even say tens of you. That's fine. Don't worry about it. But yeah. So anyways, so here's some data. So let's say I wanted to visually represent this data. One way I could do that is in a line plot. And a line plot is kind of like, I guess like, I don't know if you guys ever did this in like elementary school or something, where a line plot, well, it would look like this. It's a line. And like we had like this thing where like we'd have each student's name kind of like listed here, right? And then like they'd each get a star for every number of books they read or something like that. So let's say I've got apple. Man, I'm not actually going to ever be able to write at an angle like that. Here we go. All right. So apple, orange, banana, pineapple, kiwi, and coconut. All right. And in a line plot, they actually would, it's kind of more visual perhaps, conceptual, but they'd actually like draw a picture for every data point they had. So like, for instance, I could draw an apple for all of these. Let's see, do I have a cool idea of what I could do here? Ready? Right. I think I'll run out of room if I do this though. Let's see. I don't know, should I actually draw an apple for all of these? This is just going to take forever. You know what? Yeah, 5 apples. 1, 2, 3, 4, 5. Bam, 5 apples. Aha, perfect. Right? And then I would draw an image for each of my oranges. Hey, look at how good these oranges are drawn. So accurate. So you can see 5 oranges, right? And then, oh, only 4 bananas. Here's my 1 banana, 2 banana, 3 banana, 4 banana. There. Bananas I can draw quickly. Pineapples. Only 4 of us like pineapples. 1, 2, 3, 4. And I'll tell you what. Here we go. Now they're pineapples. Right? How great is that? Right? And I would draw kind of like an image for each of these. Bam. Now it's even better. Bam. You could live in this under the sea if you wanted. Yeah. Oh yeah. And then let's see. And then lastly we had. Wait. Oh, kiwi. Yeah, my kiwis and coconuts are going to look similar, I think. Yeah, that's what I'll do. And then coconut is 1, 2, 3, 4. And then I'll draw a little hole in them maybe or something, I don't know. Bowling ball style. There. Whatever. So that's kind of like a meh representation. But if you were a fan of pictures and you're like, all right, I understand banana, I understand the number 4, but what do 4 bananas look like? Right? And you really were a visual person and you wanted to see, oh, okay, 4 bananas looks like that, right? That's a way you could represent data. But it starts to, I don't know, it's got its limitations, I guess, over time that we'd want to consider. So that's what a line plot is, where you actually have a kind of visual picture for that. Now an extension of that would be a bar graph. All right, bar graph. Here we are. And for this, I might actually, bam, here we go. Here's our data in Excel. I'm going to select this data. And if I go to Insert Chart, is where I pulled up this little menu here. I've got all sorts of different options. I think I can select bar graph. I guess technically in Excel they call bar graphs are horizontal, column graphs are the vertical ones. But I could make a bar graph, look something like that, and look, voila, I've got this nice little bar graph. It's got all of my data on it. And tell you what, I'll even copy and paste that into here. But it kind of just removed the pictorial representation of the stuff is kind of what that ended up doing. Right? That's, you know, it's representing exactly the same thing. It's just this time now I've got, you know, bars representing it. And the height of the bar represents the quantity of each of those things. Right? All sorts of good stuff. So there's my bar graph. Right? And you guys are working on that steadily. There's a special kind of bar graph called a back-to-back bar graph. So let's say, I know you guys are probably working on making your little bar graphs and stuff. You weren't able to as quickly assemble it as I did. But feel free to keep drawing because it's going to take me a moment here anyway. But let's gather some more data. Let's say I broke my data up into two categories. Yeah, male female sounds good. We'll do female male. So you know, I don't need us guys to go first. You know, I'm not. Well, ladies first. How about? So let's see. How many ladies liked apples while you're still working on your bar graph? I'm assuming, yeah, it was all three, and then both. Oh, let's see, 2. There we go. All right, all of us liked oranges as well, right? Bananas, I think it was only 2 of the ladies and 2 of the guys. Pineapple was similar. Kiwi was everybody again, right? And then coconut, I think it was all of you guys and then not me. So something like that, right? So if I wanted to make a back-to-back bar graph, well, let's see if I could actually set this up. I think I'd actually have to, in Excel, it doesn't have a quick way to do this. Let me go to bar graph, and I'll do one this way. And then I'll do another one this way. Let's see. Where's it going here? Show up. Oh, did I click it too many times? No. And I think there's a way, if I recall. Oh, it's thinking. Pinwheeling. That's fine. Keep thinking, Excel. We're good. I think there's a way that I can, under properties, flip the direction of the axes. If I recall, where is it hiding? No. This is all. Let's see. Change chart type, format chart area. Let's see if that's in there. No, that's kind of the same-ish. Let's see. Format axis. Scale. Values in reverse order. There we go. So I could actually have my thing set up, and you can kind of eventually approximate this and get it to kind of work. And I'd be able to, I'll just copy over that. And I'll delete that, let's say, in that. Bam. There we go. And you guys would have the idea of what a back-to-back bar graph would look like, something like that, right? Mm-hmm. And they're not actually all that useful in my mind, sadly. I could actually even change these labels, I think, so it would say the different types of fruit and everything. But let's just say that's good enough. Bam. And I guess it would be valuable to know in this case that, here's my sad attempt at a back-to-back bar graph, but that's good enough. Right? It would be valuable to know the number of each subset, right? Because it might just appear like, oh, looking at this data, men like fruit less than females. But no, that's not the case. There was just fewer men in the survey. So it would be worth kind of pointing out that in this case, maybe n was equal to 2, and here n was equal to 3. My sample space was slightly different. And then I could label all of these, my apple and orange, all of that stuff, and go from there, right? So a back-to-back bar graph, that's another way of visually representing data. I would say it's kind of more valuable to have them side by side. Let me delete this. If I just do kind of like a side by side column or bar graph, something like that's a little bit more valuable, because then you can kind of more easily compare the heights of those things, and you can kind of see that a little bit better. So this is like a side by side. What's it actually? Clustered column graph. There's also stacked column graph, so that's kind of cool. So you can see each category, but then the height of the bar is the total sum of people who like that fruit. So that's actually a pretty helpful one. Let's see, what's that? Oh, that does percentage. Good stuff. So Excel has all sorts of different things. It also can do them in 3D if you're fancy, but in that case, it's actually really difficult to read the actual heights of those because of the perspective drawing. I find anyway. Let's see. Why is it yelling at me here? Oh, it's yelling at me. Change the data series. Yeah, sure. Bam. There we go. One of the things that you can do, I believe, is let's select add data labels. There we go. And by adding data labels, the heights then are kind of automatically tallied up for me. If for some reason I was doing like the angled one, having the label on that so I don't have to try to figure out like, let me get a ruler and with this perspective value be able to accomplish that. So having the data labels would be good. So now there would be a time in which a 3D, three-dimensional bar graph would be helpful. And let's actually talk about what that would be. What if I broke this up into blonde, man, now I can't think of how to spell brunette. Brunette? Sure, good enough. And then let's say red, I think is the color hair options we have here. So let's say I wanted to kind of compare all of this. Also, cool thing about Excel, I don't know if you're realizing that, is as I'm changing the data, it's live changing the graph. So let's see. So for blonde people, are there 3 blonde people here? Is that what we'd consider ourselves? Colin, Henrietta, and myself? All right. So how many of us liked apples? All of us. All of us. Bananas was all of us. Pineapple was all of us. Kiwi was all of us. And then 2 of us for that. Let's see. For brunette, there's only 1 of us. Christiana, I'm going to call you brunette. I think that's accurate. Did you like everything? All right. And then let's see. Amber, you liked everything except pineapple and, oh, it was pineapple, banana, and you liked kiwi and coconut. There we go. All right. Now let me actually reselect my data. And in this case, a 3D clustered graph would be, no, that's not quite the one I'm looking for. Not quite the one I'm looking for. Actually, surface ones are really cool too. Sometimes you can do interesting stuff with that. But where is my 3D bar graph, guys? Where is it? Area. Because it's wanting to just do 3 separate bars. Huh. No. Yeah, you can do all sorts of weird stuff. No, not quite what I want. Yeah, here's kind of what I was going for. But let me see if I can find a non-pyramid version of that. Here it is. Aha, bam. So here is a 3D bar graph. I won't ask you guys to draw that because I don't think that you'd necessarily be able to, quickly anyway. And I would say this is definitely a case in which not having labels at the top of them, like like if I'm looking at the one in the back, I don't know what that means. You know, like trying to read that across, because like the one in the back, it looks like the height would be 1.5, but it's actually only 1 there, because you have to consider that the height of the scale also shifted. So yeah, these aren't super helpful either, but sometimes it's worth you know, being able to compare multiple categories of things. Let's see, add data labels, there we go. And it looks like it wasn't even able to fit the label of brunette in there. But that's what it would look like, something like that. No, it's got chart area there. Let's see, come on, come on, here we go. Here we go, Excel. I don't want it to say chart area, go away. There we go, aha. So that's what a 3D bar graph would look like. Right, so all sorts of different ways you can present your data. So this is a three-dimensional bar graph, right? Good stuff. So that's just some different ways that you can present your data. But what we're going to talk about now is a frequency distribution. All right, a frequency distribution. Now, these categories were kind of very clearly defined. But in a frequency distribution, it'll be kind of more like the kneecap question we had just done. That was a visual representation of a frequency distribution. But let's talk about chart sort of representation of it. Frequency distribution. Where's my mouse at? There we are. Let's see. I'm trying to think if there's any quick data I could gather on us for frequency distribution. Well, let's just make some up. Here we go. Let me just open up a new sheet. Bam. There we are. And I'll change the view so it's normal. Seriously. And we'll change this to like 150. There we go. So let's say I've got some, I don't know, grades or something like that. And let's say my grades are, let's say we had like 88, 92, 100. Let's say I had a 75, 64, 21. No, that, yeah. We'll do another like 71. And let's just, I'm going to power through and make a bunch of numbers here, right? Yeah, that's fine. So 88 would be the mode of the data, I'd guess. And let's say I wanted to make a frequency distribution of this. Well, let me grab this, pop this in here. And there's a couple things that I want us to consider in a frequency distribution. So let's say these are a list of grades. It probably would be helpful to sort those in numerical order. But in a frequency distribution, I'm going to be interested in, I guess, determining kind of what range of scores I have. So let's sort this list. And Excel can do that for us. There's this quick sort right there, selecting that. And looking at this list, what is the range? You guys know what the range is? Do you know mathematically what range means? Range actually has two definitions in math. Yeah, the range in data and statistics, it's the max, the highest number, minus the lowest number. Let's see, is min? Yeah. All right, is the definition of range. So this kind of covers a span of 36. All right. Now, what I'm going to want to figure out is a class interval, all right, for this data. So I'm going to want to try to break this up into categories that I can sort the data into. And I guess like I could have categories of, let's see, we'll have class limit, and this will be low, and class limit high. So for instance, I could have a category of, well, let's see, my lowest number is 64. So I could count from 60 to 70. And my class interval would be from 60 to 70 is what I'd be talking about. And the range of this class is 10. And 10 is probably a good range if I'm talking about grades, because typically our grades scale, kind of the letter grades associate with those nicely. I also could, yeah, not at ours. I could also have like the range be 5 and go from there to there, right? So let's say I go by tens, all right? In fact, let's program this in. Insert above there. Let's say the class range is 10, and let's have a class start. And I'll say that's 60. So this cell is always going to equal whatever the class start is. This cell is going to equal whatever the class start is plus the range, and the range is always going to be the same amount, so I want to $$ that. That's called an absolute reference, so that's always going to be the same. Let's see, so the next range, or the next limit is going to start at 70, all right, is the idea. And this one I can drag down like so. And I think if I drag these down, I believe I've programmed this so this will work. I don't need those ones in this case. So that's kind of what I'm looking at here, right? Is these are my ranges. So 60 to 70, 70 to 80, 80 to 90, 90 to 100. And in the case of a frequency distribution, we actually are interested in greater than or equal to 60, your lower limit, and less than your upper limit. Okay, so this category, if I, for instance, had a number 71, it would fit into this class. If I had the number 70, it would also fit into this class. If I had the number 69, it would fit into this class. Okay, if I have the number 60, it would fit into this class. So it's equal to these numbers, less than those numbers. All right, or greater than or equal to these numbers, I guess. So if I want to figure out the frequency of this data, I want to figure out how many of my data points fit between 60 and 70. Okay? So how would you logically figure that out? Going through the list. How do you know how many are between 60 and 70? What would you do? Count what? So I look at the number 64. What logically do you compare first? Is it bigger than 60, bigger than or equal, right? And is it less than 70? So I'm going to do some count ifs here. Equals, count ifs, all right, criteria range, we'll do this. And criteria 1, I'll say, or actually no, I want to compare it to this whole thing actually. And the criteria, I want it to be, is it greater than or equal to 60? Right, is what you guys said. But that's not the only limit that we wanted. I also want to know, is it also less than this one, right? Is that what you guys described? So I want to count all of the ones that are greater than or equal to 60, but less than 70. And actually, I'm going to $$ these, because I'm going to mess that up in just a second if I don't. Because I want the thing I'm looking at to always be the same. So I'm just trying to program this in Excel here. Like so. And why isn't it working? Does it not want the parentheses or the quotes around it? I thought it usually does. No? Huh. Why am I having trouble with my COUNTIF formulas today? I think I might have to do this and then do a ampersand. Wait. Quote, quote, ampersand. Let's see if that works. There it goes. All right, aha, I fixed it. So now this formula, I just want to point out, I'm counting the number of numbers, right? Counting the frequency in my list that is greater than 60 but less than 70, right? And that's logically what you described. And now theoretically, if I program this well, I should be able to drag this down, and the next one will count between 70 and 80, or 80 and 90. And I think I've done it. All right. So look at this one is going through this list. Is it greater than or equal to 70? Is it less than 80? Right? So it looks like this is programmed correctly, right? Go through this list. Is it greater than or equal to 80? Is it less than 90? And you guys would have been able to figure out that frequency a lot easier, right? But to represent this, I guess kind of on paper, you guys would have drawn something like this, where a frequency distribution is literally a chart where, oh, let's see, where's my pen tool? You would have had something like scores, right, or grades, and in your first column, and then the frequency in your second column, and you would have said 60 to 70, 70 to 80, 80 to 90, and 90 to 100. And then you would have just counted, and you would have gotten the same numbers as I did, right? You would have had 1, 3, 8, and 3. All right, so this is a frequency distribution. It's not as visual. It's more just like an arrangement. It's data present, right? But it's kind of better than just this list, I guess, right? And that's the idea, is I counted how frequently I had any data between 60 and 70. All right, is the idea. Now, let's see. So some of the things we had going on there, right? We had the range was kind of the range of each class. Let's see. So the class interval is actually a better way to describe that, is the range of each class. So in this case it was 10, right? We had the class limits. All right, which was kind of the lower and upper bounds for each class. Boundaries, right, is what I mean by that. And then this thing is going to show up later, but we'll have what's called the class marks. And the class marks are the midpoint of the limits, is probably how I describe it. Yeah, the midpoint of each class. And we'll end up using that to do some calculations later. So for instance, the class mark of this class would have been 65, 75, 85, and 95. All right, that would have been the class mark, is what we'd be referring to there. All right, so this is okay, I guess, representing it this way. It's just a chart, right? It's good to know that frequency, and notice it's kind of similar back to this, all right, where I was just kind of figuring out how many people like these different types of fruit, right? It's a similar idea. But there is actually a visual way of representing this, and that visual way of representing it is called a histogram. Let's see, and a histogram is a very special type of bar graph. All right, so it's a bar graph of a frequency distribution of an FD, right? And the width of the bar represents the class interval. And the height of the bar is the frequency. right? So how many data points fit within that category? So let's see if we can get Excel to do this for us. So I would be interested in, actually, maybe I can, what if I drag this over here, and I guess I'll call the, maybe I'll call this label, and I'll, ready for this, some more Excel for you, concatenate. I'll do this, I'll throw in a little dash of that, and then I'll throw that. So it's just going to kind of give me a label here, or I guess I could call the class. So if I select this and I want to make a frequency distribution, well, it's going to be a type of bar graph, really, right? And it's going to look like that, except what was the stipulation on this? It said the width of each bar is the class interval. So here's just a plain old bar graph. So I'd actually have to, in the options, gap width, change that to 0. And now this is a true frequency distribution. All right. That's what a frequency distribution looks like. Right, and I guess I could have labeled this, scores or grades or something like that to make it more clear. And you can see that the height of each bar is in fact the frequency of each of those, right? 1, 3, 8, 3, right? So I can see that. Technically, it might make more sense for my labels to be 60 to 70, and then 80 and 90 and 100, right? To land right there. But I've never been able to get Excel to do that proper. And so question, if I got a new grade and it was an 80, which category would it go in? It'd add into this category, right, is where it would end up going, right? So just I want to point out that if it's right on the line, it's always to the right, okay, is kind of how that goes. Now, there's also this concept called a frequency polygon, which is kind of a extension of this. Let's see, what was the class mark? I'm going to drag this over one more time. I don't think it'll yell at me. Class mark. Let's see, how could I program a formula to find the class mark? Class mark was the midpoint of my limits. How would you find the midpoint between these two things? I mean, we know it's 65, but how could we calculate that? Add them? Divide by 2, yeah. So, okay, all right, there we go. So notice, Excel, if you tell it what to do, it'll do it. So a frequency polygon, let's see if I can find it. I think it might be under area. No. Frequency polygon. Let's just hit all. Actually, it might show up this end of things. I'm getting closer. Closer. Yeah, all sorts of crazy ways of representing your data. I think this'll do. No, it's not doing it. Well, let me show you in another spreadsheet that I have. And I'm actually going to program this with you guys in a little bit. Here is an example of a frequency polygon compared to a frequency distribution. Basically what it will do, that's actually not quite, well, oh no, it is because the labels are different. It basically will connect the dots of the midpoints of each bar, is what a frequency polygon does, is the idea. So if you imagine a frequency polygon here, it would just kind of connect these dots. right? Something like that. And it would be, the polygon would then kind of represent, right? You could find the area of that and do all sorts of different things, and you could see where kind of the majority of it occurs. We won't do a lot with frequency polygons, but I just want to point out that's what that would look like. So that's what we did today. That's it. Right, the class marks down there. What kind of chart is this? Will it tell me? Change chart type. What type was it that I got away with using? I don't know. No, that's... Huh. Well, that's fine. Whatever. Whatever. So anyways, thanks for watching, internet friends. Have fun. We'll be doing some more data later. Later.